Alright, this is your video for your specific heat capacity lab. In it, you're going to use a process called calorimetry to determine what the specific heat capacity is for an unknown metal. You're going to have a little piece of metal and you're going to put it in a coffee cup calorimeter and use that to determine what your heat capacity is for that metal. You will be doing that with 4 other metals of known identity. And what you're essentially going to do is you're going to graph your actual heat capacity or your actual specific heat capacity versus your experimental specific heat capacity. So first thing we need to do is we need to identify what your metals are for your actual heat capacities, and that's what I have right here. So make sure you have these metals down, okay, in your notes. We have copper, which is 0.387 joules per gram degree Celsius. We have steel, which is 0.120 joules per gram degree Celsius. Aluminum, which is 0.900 joules per gram degree Celsius. And lastly, we have brass, which is 0.380 joules per gram degree Celsius. Okay. Now, what I'm going to give you are small metal samples. They'll be little cylinders, which we call slugs. Okay, you'll have 4 metal slugs, one of copper, one of steel, one of brass, and one aluminum. And then you're also going to have a little irregular shaped piece of metal, and that is your unknown. Okay, so how you're going to determine your heat capacity, again, we'll talk about that in class. This video is to show you what you do with that information once you have acquired it. So I'm going to go ahead and, just for simplistic sake, I did my calorimetry lab, and my copper heat capacity when I was all said and done was 0.431 joules per gram degree Celsius, and then I'll just make up some other ones, 221 joules per gram degree Celsius, 0.94 joules, or 0 joules per gram degree Celsius, and 0.377 joules per gram degree Celsius. Okay, so what I have here is I have my actual in black, and I have my experimental in blue. Okay, so if I go back to my graph, this is where my blue numbers are going to be plotted, and this is where my black numbers are going to be. Okay, so when I plot these data points are going to be, just for simplistic sake, I'm just going to put 4 random numbers, or 4 random points there. Okay, and once you have those 4 points, you are going to determine your best fit line. Okay, you get a ruler. Obviously, unfortunately, I cannot put a ruler on this board without it freaking out. So I'm going to probably not have a pretty line, but a line. Okay, that is my best fit line. So you're actually getting 5 experimental heat capacities, right? You have your 4 that you're listed here, but you also determined the heat capacity for this substance right here, because you did the same process with the slugs that you did with the piece of metal that is unknown. So you're actually going to use your what we call a calibration curve, which is this line right here, and you are going to determine what your actual heat capacity is for that metal, and then look up what that metal is. So for example, let's say I did my my unknown piece of metal, and my heat capacity ended up being right here, right on that line. So what I'll do is I look over here and I find out what that heat capacity value is on the y-axis, and this is the actual heat capacity, specific heat capacity for the unknown metal. And then what you'll do is you will research that metal and find out what its identity is. Okay? So, just a refresher, again, you are going to do a calorimetry lab, and you are going to derive four specific heat capacities for your four known slugs of metal, copper, steel, aluminum, brass, and you're going to plot them on the graph. You will then do a best fit line of that 4 points, and then you will take whatever your unknown was, this guy right here, and you will plot him on that same line, on that same graph, and you're going to go up here, find out where he is on that line, and then mark your way over to get to the y-axis to find out what the actual specific heat capacity is based on your data. Once you've identified what the heat capacity is, then you do your research to find out what the metal is. Okay? So, tomorrow, like I said, we're going to discuss how you're going to do this. This is a video showing you what you're supposed to be doing with it. Okay? So, day one, you're going to identify your metal bag number. Each one of the bags is going to have the 5 pieces of metal in it, the unknown and the 4 slugs. Okay? You need to mass each metal that's in that bag. And the reason why you want to identify which bag number you have is because you're going to come back the next day for day 2. You want to make sure you have the same bag because you want to make sure you have the exact same slugs, since you spent part of day 1 getting the mass of those metals. Okay? And you're also going to become familiar with how to use your LabQuest 2 interfaces. Okay? This is what we're going to use in lieu of a thermometer. Okay? You are going to use a temperature probe to measure to the 10th of a degree Celsius any temperature changes that are occurring. Okay? And again, how you're using the LabQuest 2 is going to play a role in my description of your lab tomorrow. So probably you'll come in, you'll get your metals, you mass each metal. After you've massed your metals in the bag, you're going to return the metals to me, and then we'll have a seat and we'll get working on how you're doing your lab, including how to use your LabQuest 2, and then if there's time the rest of the period, you can go back and play with the LabQuest 2 and play with the interface, the temperature probes, so you know what you're doing with it. Okay? Day 2 tasks, so I'll give you additional information tomorrow, or during day 1. Bring the metals to a thermal equilibrium using calorimeter. Okay, you're going to calculate the specific heat capacity of the metals and graph them on graph that data on your calibration curve, which is what we talked about in this video. And then identify your unknown metal based on the specific heat capacity. So, granted, this video really talks more about these guys right here. Okay? And the reason why I chose to talk about the latter two is I want you to know where we're going with this. The purpose of this lab is to calculate a specific heat capacity of the metals and to graph them, and then use that graph to identify your unknown metal. That is the purpose of this lab. How we're doing the lab, again, we'll talk about on day 1.